second last session of today. My name is Michael, I'm your track chair and I'm your presenter. So I can probably do whatever I want in this session and you guys have to listen to it unless you're moving out. Alright, so I work for SAP and I would like to give you a quick overview of why data management is really strategic for data science project and what is the SAP positioning for it. So let me start the watch that I at least don't get out of control totally. So maybe quickly to get you into the picture what we're talking about this afternoon now for the next 25 minutes. So this is the SAP strategy in total. You probably are aware of the application piece that SAP does. So we do ERP, we do HR solutions, we do CRM solutions, and we have naming for that. That's what we call Intelligence Suite. This is where we build in machine learning algorithms from scratch by using our technologies, which is basically here in the middle, our intelligent technologies, which is integration of open source, but also our own machine learning topics that we are developing based on the applications. And at the very bottom, the digital platform that is basically all about how do we handle the data in the best possible way for such a intelligence suite, for ML and artificial intelligence and predictive analytics, and in general for data science projects. So we are talking about topics around here now for the next 22 minutes. So the real question is, why do we do that? Why is SAP doing that really? And then I will answer the question of who should be interested in it and how does it really work. Alright, so let's do that. And I mean, everyone knows 80% of the time you're dealing with data before you go into applying algorithms being applied to it is about managing data. And this is really, today we have a lot of data, we need to make sense out of that. And that is the reason why SAP does that. It's not just for our own applications, but it's really that we're establishing a platform that data can be treated and really build that back into a business process. Whatever the algorithm is, whatever the machine learning thing that you want to do, application that you want to develop and do, we want to bring it back into an application, into that's what we do from the very, very start since SAP started. And, you know, this is all about this. It's about self-driving cars. It's about, you know, treating data very quickly, using the data, building platforms for a company like Tesla, and also bringing new services to the table. New services could be something like a robot company like Mitsubishi saying, okay, I am basing new business models based on what I deliver from a hardware perspective. Individual maintenance schedule, self-service support, equipment health. I deliver that to my clients. This is why they need to handle data in a good way. And this is not just sensor data, but there might be also information about when has the last maintenance schedule happened, when is the work order supposed to be triggered to do that. And this is obviously where SAP comes into the game again. So we are trying to build the piece around big data and data into the application world. And the same is valid for our customers. More customer-oriented, targeted marketing. We want to get, everyone wants to get closer to the customer. That's why all those applications on our phone actually exist. And that's why, for example, a project that we have realized together with a company went like this. So we said, okay, we built an application for you, and we take pictures. We take pictures of your shirt and say, all right, that's a nice picture. What is it? Is it really a shirt? Is it, you know, the pullover, the sweater that you have on? And we want to recognize that this is a shirt. And we want to link this in our web shop, and that's the app that we have developed together. So it is probably a Lacoste shirt that you have on, but there is also a Tommy Hilfiger shirt. So product recommendation. using SAP technologies for that. And in the end, as I'm standing here in Bern at the Kursaal, I would actually want to know where is the next shop that I can buy that shirt or the recommendation that I'm getting. Now this is an easy app, it's easy realizable over the phone, but if you really look at it, you know, from the idea, you need quite a lot of code, you need quite a lot of data, and you need quite a lot of algorithms to actually realize that. Now have a quicker look at this. So this is sort of the app that we see, and this is how it works. So first of all, it would really be great if I am, as a customer using this app, would be somehow identified. So I need customer information in that app that I expose. And that is often used in CRM systems, so that data comes in and says, okay, that client is already a client or is not a client, so we can identify if it has been doing actually some purchasing before or not. We would actually want to integrate data in this application of where the location is of that person at that point of time. So again, this information needs to be available real time and make sure that it is correct, because we want to do a recommendation of where the shop is that he can go and buy that shirt. And it would be really, really embarrassing if I send someone to a shop and that shop is out of stock, or that t-shirt that he has been taking a picture from is not there. So I need to integrate data from more logistic, from ERP points, that I really want to make sure that I'm not sending someone to a shop that is, doesn't have the shirt. But it would also be probably good if we integrate logistic information, because then we sort of know if how expensive that shirt potentially is, and we potentially want to also do the recommendation, because the Lacoste shirt that have taken a picture from, and I want to give an indication, the Tommy Hilfiger shirt that would be very similar, that kind of topics might not be solved there. So we need, first of all, image recognition, which is, in that case, we have used the TensorFlow model to do the image recognition, and we have used the Weblogs and S3 Amazon data buckets, basically with Spark and Python, to do the product recommendation. So if we look at this a little bit, so this is very much existing IT driven, where the classical data that you gather in ERP systems, CRM systems, in transactional systems, while the new technologies that are Python or machine learning topics is not our stake. It's probably open source and other technologies that you want to use, but really we need to bring that together at that point of time. Because again, if my boss comes up and asks, now great, you have a great app, you can take pictures and you can do selling of shirts, how many more shirts have I really sold through that app? Probably comes back into your classical environment where you do dashboarding and do analysis in a very financial environment, where again often this sits in existing IT. And the linking of this is where we actually focus on with new solutions from SAP that I would like to introduce to you in a couple of minutes. Now, again, we talked about why do we do this. So first of all, such kind of data-driven applications is something we want to enable. It includes many different technologies, and hence something that we need to open up from an SAP perspective to expose data from our own environments, from our own technologies and applications that we have in place, but also really open up to integrate that with different other technologies that are there, like TensorFlow image recognition and other machine learning frameworks. Another example of that would be this one here. It's another project that we have done with a company. They are using the smartwatches and collecting data from those people running around out there. It's a company that is doing sweaters and sportswear, so sport shoes and shirts and things like that. But also they have smartwatches. So this information is gathered, is collected. You can see a little bit of what kind of information is collected. That's just the UI5 front end, so don't worry about it to visualize the data. how many records that we are coming in, from what are the people doing, are they running, we can cluster that, are they cycling, and what are they doing really, and where do they sit? A couple of them in Europe, the rest will sit somehow in the US, so it was a US company who realized that, right? And that's the information, the IoT information that we gathered from them. And it's brilliant, but with that, we have then started to cluster this information, saying, okay, there are people that are casual joggers, persistent runners, enthusiastic sprinters, and professional athletes. So we could cluster that. How often do they go and run out there? How often and how long do they jog, for example, or do bike cycling? And we could then see what have they bought, what kind of products have they bought, the enthusiastic sprinter, for example, or the casual jogger. So that is bringing then together the classical ERP information with the IoT, and we could then start looking at the casual jogger saying, all right, those are the products of the casual jogger, and in other countries, Italy, Australia, Singapore, those guys have bought those products, and we have potential upsell possibility in that space, and that's the revenues in billion that we could potentially bring to the table if we do kind of campaigning. So again, that's a very trivial example of how we use IoT information. In that sense, the people using the sports clothes of that company and bringing it together with business data to do the evaluation of business potential for that company. So that was point number one. Point number two, why we do this, is beside enabling data-driven applications, we want to make sure we have a broad user acceptance of this. So, there are people sitting in there, the data scientists, who have their own environment, they want to work in their own environment, here Python notebooks, and they want to go away from that. So, although SAP has this kind of technology that data scientists could work with, in the end, we don't want to force anyone doing that. If they want to run R code, Python code on our data that sits on our databases and data platforms, fine, go with that. No need in actually changing the skills of that. There might also be people like the business analysts, they want to have self-service, they want to use no SQL, or they want to use SQL scripting, okay, fine. And the IT developer goes in and says, okay, Java, I want to build my application on Java. There might be a guy sitting somewhere in a BW, so business warehouse environment, that sits in the SAP stack and says, I have BW skills, and I have HANA skills. That's the classical technologies from SAP. I can use that, and I want to use that. And there might be also the people, the business user, they just want to see the app of taking pictures. And in the end, there is also the guy who actually has to run that. Just imagine to have the app for image recognition with the shirts going on. Someone needs to maintain that and have the operations in IT settling that. And that's something where we are open enough and say, okay, we are providing our data management solutions. I'll introduce you to the product in a minute. And that's what we want to do to make sure that all of those people who have their own skills can actually do that with their own skills without changing the complete skill sets. Because that's usually the environment to have the people working on data-driven applications or machine learning environments. So we want to integrate that. Show you how in a minute, and we want to make sure that the guy who has developed the app for taking the pictures of the shirts, that when that is proof of concept has really been done, that he can scale it out. Now suddenly you don't have only 2 people using it, you have hundreds of people using it out there on the street because they have registered and want to use that. We want to make sure that we can bring such a project from idea over to a larger pilot, making automation and industrialize such kind of projects. Meaning also that we are using certain technologies to facilitate that by having the pipelines in place, having everything that will enable the IT to operate such an environment and not just have it on one single area on a computer laptop run and work, but never been able to scale. And I think that's where SAP has been, from an enterprise point of view, always there in large, scaling it out large, and that's what we want to do in data management and in machine learning projects as well. So now let's have a quick look at what that really is. That's the product, that's the platform that we are bringing together. So on one side, it's obviously everything around the HANA side, and for the people, the quick thinkers inside here, before you had existing IT on this side, now it's on this side. So don't get confused. So this is the SAP landscapes. On our HANA platform, the ERP is running older ERPs, but also business warehouses, and it could be not also applications built on HANA, but also if there are other existing systems. Obviously, it's an SAP presentation, I can't put any other existing system on there, so please excuse. There might be others as well. There are others, so they are included in this. And on the other side, you see distributed data systems, meaning as well that these blocks are representing data that is not part of an SAP system. That might be IoT data, for example, that sits in cloud, that sits on technologies such as Hadoop, and we want to bring that together. Basically, the SAP Data Hub does that for us, and the product includes the runtime environment that makes sure that data from sources that are non-SAP can easily be linked and visualized in a runtime. So that's basically the visualization piece and bringing it into a structured way so that the data can be linked to existing ERP systems or data sitting in the HANA environment at these ERP environments. So first of all, the product also helps us to do holistic data landscape, so it does data discovery and metadata governance, meaning all the connected systems into the data hub can be visible where data sits, what the data includes, and how good the quality of the data is. Please don't forget, this thing is not a persistency. It is an orchestration layer that will help you to look into data into different sources. That sits in the cloud, on-prem, in distributed data systems, and in existing systems, SAP and non-SAP environments. So we don't want to suck everything in and start analyzing it. We want to keep it where it is and do the processing of the data where it is and push down logic into those areas or into our own environments or where the execution and processing of data needs to be done. And that's the data hub with functionalities on the landscape management, first of all. Second one would be more the pipelining topic, so flow-based data processing. Imagine again in the app that I need to extract ERP data, I want to wrangle it, I want to transform it through technologies that are open source or through other technologies that might be also from SAP and others. You need to build a pipeline from A to Z, from extraction to transformation to applying machine learning into pushing it somewhere into a dashboard or pushing it into another front end or into a database. That's a pipeline that we need to build. That pipeline can be built up in the SAP Data Hub and included also through Docker containers, technologies that are not SAP. So we build up runtimes in those pipeline that can be R, that can be Python, that can be TensorFlow, where it is spinned up, calculations are being done, processed in the cloud, and then pushed into the next topic in the next pipeline. And last but not least, quickly, we also have the whole connectivity and ingestion topics. That's basically the piece to integrate data from the different sources, which are SAP, non-SAP, and in the areas of distributed data systems. So we can, with this, basically fulfill those three areas with this product to have data-driven applications enabled, to have the operationalization. So IT monitoring is included in this as well, especially in the governance piece, for example. And there is obviously the topic of making sure that integration is there. So, quickly, who has seen this piece before? The Borg, exactly, the Borg, wonderful.
Being simulated.
Ah, wonderful, perfect. So there is a Star Trek lover in here. Lovely. So probably you guys know that Google has used Borg as an internal project name for their own landscape management. So imagine completely distributed landscape of processing power. The internal project name was called Borg, that they have done and used and open sourced on the Google Cloud Platform as well as in others in Kubernetes 5 years ago, roughly 2014. So that has been set up, and Google has been pushing their internal project name open source to make sure that this can be also used by other companies, and SAP, for example, does that heavily. So the product that I just showed you is a cloud product. It is can be deployed on-prem. We really don't recommend that, but still it is possible because you need to set up a Kubernetes environment. We are using also, as I mentioned, Docker containers where you can basically bring in your technologies such as R and Python, TensorFlow, images that you have already programmed on maybe a data scientist laptop, and bring this into a container to make that available in your pipeline inside the Data Hub. So things that you have invested in already today in your data science projects can now be handled with the SAP Data Hub as long as it is Dockerized or can be Dockerized. So that's the technologies the solution is built on, and obviously as we are not having our own very infrastructure as a service platform, we are supporting all of the sort of hyperscalers platform from Huawei, AWS, Azure, Google Cloud Platform, but also, I mean, there are certain on-premise deployments that can be used as well. We are supporting them too. And therefore, that product is something that you can consume out of the cloud if you want to go the easy way. And if not, use an on-prem environment, it's possible as well, but infrastructure-wise, it's just a larger effort to actually go forward with that. So again, that supports the SAP Cloud, multi-cloud strategy. And basically, I have one more slide, and then I'll open up for a couple of questions. What can you really get with this? I mean, we are focusing with this on data management. We are saying that if you have a lot of distributed data sources, on-prem cloud environments, we can help you to bring that together, apply machine learning code that you have already in place, and bring that into the Docker environments in the Data Hub. And we really want to say that with this you can be quicker also from an operation point of view when you want to operationalize such a kind of a project from A to Z and want to scale it out over a larger environment. So that's it, and I can see that I'm quite in time. As I'm the chair, there might be a couple of questions that I can help you with. Otherwise, there is a booth downstairs that you can get your earpods as well. It's a free giveaway. So use that as well. So other questions? Yes?
I must admit, I thought we were going to talk about data management more in terms of governance perspective. So can you say something about the governance features inside of SAP DM? it was in the architecture, the functional view you showed before.
Yeah, so the governance side is really, first of all, establishing the connectivity to those systems that are wherever they are. Can be SAP, non-SAP, or cloud environments. You will have the possibility to manage the accessibility of towards those environments. You have the possibility to screen those environments as well for data quality. And if you are preparing a data set, for example, meaning that your data science team has came up with a data set that should be used for further projects potentially, that can be tagged, and it will be visible for other people by knowing the tag or knowing where that sits. There is also a possibility to search.
Discovery.
No, the search functionality across those different environments. You're looking for customer data, put in customer, and it will show you where customer data sits. Obviously the tagged information will come up as well, but it will go through directly into the columns, into the different data buckets, and look for the key term customer, and will also surface that where customer information sits. So that's just some of the governance topics. It's not the classical, let's say, master data governance topics in there. It's really something that is related to the connected systems that are distributed wherever they are sitting, and sort of a metadata catalog where certain governance of the data sets and the data is happening. Okay. So data management, that's maybe a point I'd like to take up. Data management as such is obviously part of that whole topic, but it's rather something where if you have a data science project, this will help you to operationalize also your data management skills. It's not just the classical integration topics and things like that. Okay? That brings me in 26 minutes and 46 seconds. Maybe a last question, otherwise we'll close it down and let you jump. Yes?
What are your main customers for this system right now?
There's a retail company in Switzerland that has done forecasting of perishable goods, so extracting data from different sources to the forecast of the perishable good and push it into the other systems so that the farmers know when to cut how much. Target was to make the fruits and the vegetables more fresh in the markets. There are companies in Germany that have used weblog information of how people are browsing the website. That was a big online retailer that are using this. There is also a company in the chemical industry has been using this with connected to OSIsoft data, so historian data, sensor information from fertilizers that have a chemical process going on with temperature information and so on, to see that the product at the end has the right quality. In manufacturing, we have a car manufacturing company that does use by printing, the pieces of steel. Then there is an infrared picture taken that is being sort of looked at from image recognition if there are pieces that are hot during the pressing of the piece of metal, and then see if the quality of that piece is still valuable or good enough for putting it into the rest of the production, so that they have a better quality indication during the production process. So most of those cases are where data needs to be analyzed in a very, very regular environment, very quick, with different technologies brought together, and make sure that this works in a production way from an IT perspective. There is a couple of more that just don't pop to my mind now, but there's many of those similar kind of topics. Yeah. Okay, so I'll give the present to myself as well. So thank you very much. That was a really